But we're going to start with we're just going to do this one application. So let's look on the very last page of our notes. Here we are. We're almost to the end, folks. Very last page of our notes. And we are going to change 0.4 repeating into a fraction. Okay? Now, y'all know what 0.4 repeating means. It means 0.4, 4, 4, 4, 4, 4, da, 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 da. Now, believe it or not, that can be written as a sum. Take a look at this now for a second and see if you agree with me that I could break that repeating decimal up and think of it as 0.4 plus 0.04 plus 0.004. I hope that makes sense to you, because remember, when you add decimals, you line them up, or line up the decimal points. Wouldn't continuing this on forever and ever and ever, wouldn't that give me my repeating decimal? Does everybody see how that works? This is an infinite, clearly, geometric series. This is exactly the kind of problem we were just looking at. The first term is 0.4. What's the ratio? What am I multiplying by to get from term to term here? Notice I'm moving it one decimal place. So what am I multiplying by if I'm moving it one decimal place? 0.1, very good. 1/10, one decimal place. We take this times 0.1 and this times 0.1, we just keep building that sequence. So our sum, if we want to add all that up, our sum should be the first term divided by 1 minus the ratio. And the first term is 0.4, and 1 minus 0.1 would be 0.9, right? You have a calculator if you need it, that's 0.9. And then I'm allowed to move the decimal point one place on the top and the bottom. I have to do it to both. So my fraction is just 4/9. To check that, if you did 4 divided by 9 on your calculator, it will give you this decimal. That is the fraction that produces this decimal. And we figured that out by simply splitting the decimal up into a bunch of things added together, and then we used our formula. Does anybody have a question about that before we try the next one?
Why don't you move the decimal back again?
Here, because when you build a fraction, you can't have decimal points in it.
Okay.
There are never decimal points in a fraction, or there shouldn't be. And you're always allowed to get rid of them. You just have to make sure you're moving the decimal point on the top and bottom the same number of places. All right, let's try the next one. We're going to do the same thing with this guy. Now, first thing, think about what this would look like if you expanded it. You'd have a 0.63. And then the next term would be 0.0063. And then the next term would be 0.000063, and so on. In our last problem, we were moving the decimal one place. It was 0.4, 0.04, and so on. Here, because we have two decimal places repeating, we have to move the decimal point two places as we go from term to term. What will that make my ratio this time if I am moving it 2 decimal places?
0.01.
Yep. So when I moved it 1 decimal place, it was 1/10, 0.1. When I'm moving it 2 decimal places, it's 0.01, 1/100th. However many decimal places are repeating, that is going to give you your common ratio. So if you have 2 decimal places repeating, your ratio is going to be 0.01. If you have 1 decimal place repeating, your ratio is going to be 0.1. All right, so here we go. Our formula says we take the first term, which is 0.63, over 1 minus the ratio. Remember, it's 1 minus the ratio. So we have 0.63 over 0.99, 1 minus 0.01, and again, you have a calculator if that bothers you. Now I got to get rid of my decimal point and my fraction, so I'll move 2 places, and I have 63 over 99. But 63 over 99 is not in lowest terms. What can I divide 63 and 99 by?
9.
So 9 goes into 63 7 times, and 9 goes into 99 11 times. Now, some of you may have divided by 3, and that's okay, but then you would have to divide by 3 again. Now, to check my work, I'm going to take my calculator, and I'm going to do 7 divided by 11. I'm typing this into my calculator, and what better happen? I better get my original problem. Did I? Yep. Which means we did it right. So that repeating fraction is actually 7, or that repeating decimal, excuse me, is actually 7 over 11. All right, let's try the next one. Now this one is a little bit tricky. Do you understand that the 1 is not repeating? Now, what does that mean? Well, you can still split it up. I still want you to split it up. But when we split it up, we're going to have 0.1, and then we're going to have 0.04, 0.004, 0.0004, and so on. This term, this 0.1 here in the beginning, is an extra. This is the part that you're going to add up with your formula, because that 0.1 does not fit the pattern. You understand that? Remember, we're doing sequences. There has to be a pattern. This does not fit the pattern. It's just an extra. So I'm going to ignore him for a moment, and I'm going to do the part of the problem that is the pattern. The 0.0, they take him out. So it's 0.04, 0.004, and so on. Now, how many decimal places are repeating? How many places are actually repeating? 1. What does that mean my ratio is? If I have 1 decimal point or 1 decimal place repeating, what's my ratio?
Is it 0.1?
It is 0.1. All right, let me say it again, guys, because I think you guys got to wake up here. Come on, come alive. If 1 decimal place repeats, your ratio is 0.1. If 2 repeat, it's 0.01. If 3 repeat, it's 0.001. We haven't had one of those yet, but it could happen. So we have 1 repeating decimal place. So I'm going to add up my bracket. My first term is 0.04, and my ratio is 0.1. So my formula says 0.04 over 1 minus 0.1. Remember, This guy right here is not part of the pattern. He's just a random extra number thrown in. So he's going to be handled separately. Right now, I'm doing my repeating decimals, which are the 4s. So 0.04 over 1 minus 0.1. All right, so that's 0.04 over 0.9. Now, gang, you got to get rid of those decimal places, which means I'm going to have to move 2 places. But when I move 2 places on the top, I have to move 2 places on the bottom, so I'm going to get 4 over 90. Two places, move it on the top, move it on the bottom. 4 over 90. Don't reduce that just yet. I know it reduces. Don't reduce it just yet. Because that 4 over 90 is the bracket. What do I still need to add in? The extra 0.1 that I ignored at the beginning. Right? So in comes that. So I'm going to take my 4/90ths and I'm going to add 1/10. This is 1/10, that original 0.1. Now, how do I add fractions? What do I need to do to add fractions?
Common denominator.
Yes, thank you so much, Gabe. I need a common denominator. So I got a 90 and a 10, so I'll multiply this one by 9. So I have 4/90ths plus 9/90ths. This is 9/90ths. And the final answer to the problem then is 13/90ths. Now, how can I check that? That's going to be a quiz question on Friday for sure. Might even be an exam question. How can I check it to make sure I'm absolutely right? What if I typed 13 divided by 90 on my calculator? What should happen if I do 13 divided by 90? I should get the problem. So if anybody out there is awake, would you do 13 divided by 90 and see what happens? Did you get what we wanted? Yep, we did. So we got it right. We did it right. All right, let's try the next one. All right, so here we go. Again, you've got a piece of the problem that is not part of the pattern, because you all know that this means 2.33333. That's what that means. The 2 is not part of the repeating pattern. So like before, we're going to ignore it for the time being, and we're going to look at this part. So we got a 2 out here, but we're looking at 0.3 plus 0.03, 003, and so on. That's the part of the problem that we are looking at in the beginning. Okay? What's my ratio?
0.1.
Thank you so much. We know the ratio is 0.1 because how many decimal places are repeating? Just one. The bar's over one number. One number is repeating. So your ratio is 1/10. So this part of the problem will be 0.3 over 1 minus 0.1, which is 0.3 over 0.9, or 3/9. Now, I usually don't reduce at this point, but you can in this problem because it's going to be, doesn't matter, it won't make it any harder. So if you want to go ahead and reduce that to 1/3, you absolutely can. How many of you knew that repeating decimal was going to be 1/3? You've seen that one before, right? So you probably knew that already. But anyhow, we got it, 1/3. That is not the answer though. That is just this part. So what do I now have to do with that 1/3? I have to add in the 2. So I have 1/3 plus 6/3. So my final answer is 7/3. 2/1 is 6/3 when I get a common denominator. So 7/3 is the original problem. And if you check that on your calculator, it will work. 7 divided by 3 is this right here. All right, one more. Let's see if we can get it because it looks a little extra confusing. Now you need to remember that that means 1.7 plus 0.041 plus 0.00041 plus da-da-da-da. The 1.7 is not part of the repeating decimal. The repeating part starts with the 4-1. So does everybody, can you make sense of this? Does this seem okay to everybody? Remember, if you line them up, like if you're actually going to add them, you would line them up like this. And when you add, that would produce the decimal that you're talking about. Now you're going to start by adding up the part that's the repeating sequence or the repeating series. So you're only going to add up the part with the 0.041s, the 4 ones. What is my ratio this time? How many decimal places are repeating? 2. So my ratio will be thank you. So here we go. I'm going to add up the part in the brackets. So the sum in the brackets will be 0.041 over 1 minus 0.01. My first term that I'm actually adding, this is the formula for the actual sequence. So that's the repeating part. So it's 0.041 over 1 minus 0.1. So that's 0.041 over 0.99. Now I need to move the decimal point to get rid of them. So that'll be 1,241 over 990, because you got to move it 3 places. So 41 over 990. Don't reduce just, I don't even think that reduces. But even if it does, don't do it at this point, because we still need to add in something, don't we? What do we still need to add in? And I'm going to think of that as 17/10. Would everybody agree that 1.7 is 1 7/10 or 17/10? So I'm going to add 17/10 on the end here. Now, how do I add those two fractions together? What do I need to do to add 41 over 990 plus 17 over 10?
Kind of multiply 17 over 10 by 99.
Exactly. You're trying to get a common denominator. And 99 times 10 will be 990. So I have 41 990ths plus, I'll use my calculator to help me, 1683 990ths. And now I can add those together and get 1724 990ths. Now, at this point, you have to just look at it and figure out if there's any simplifying you can do. That's kind of a big fraction. 1724 over 990ths. Does anybody see anything that'll go into those two numbers? Aye, peeps. One ends in 4 and one ends with 0. What do we know goes into both of them?
We can do 2.
Yeah, very good. At the very least, we know we can do 2. So I'll divide by 2. And I have 862 over 495. Let's see, I can't do 2 anymore. Can't do 5. Can't do 3. Anybody know the rule for 3? How do I know I can't divide by 3? Does anyone know that rule? Did you learn that in elementary school? If you add up 8 and 6 and 2, you get 14, you get 16. When I add up these digits, 16 is not divisible by 3, so that means that number isn't divisible by 3. It's really pretty cool. If you add up the digits and it's divisible, then you can divide by 3, otherwise you can't. So I think that's our answer right there. I think that's our answer. Now, I'm going to double check that because we did a lot of messing around there. So if I take 862 and divide it by 495, I better get this right here. Are you double checking it with me? Are you getting that?
Yeah.
Awesome. All right, that completes the notes. So what we're going to do is do a little bit of review. When I see you tomorrow, or when I see you, you will get a review sheet. But what I want you to do right now is just take out some paper and we are going to run through a few review problems for our quiz on Friday. I'd hope to get in a quiz and a test. Not going to happen. We just don't have enough time. So we'll kind of combine them and have a big quiz on Friday. All right, so here I'm going to write some sequences down. Once you do these on a piece of paper with me, I know this is a little inconvenient, but it's all right. You can do it. Just on a piece of notebook paper or typing paper or something. Write down these sequences. And here is what I would like you to do. I want you to look at those sequences. I want you to tell me if it's arithmetic, geometric, or neither. And then, if it's arithmetic or geometric, I want you to tell me the common difference or ratio. So this should be pretty easy for you. Take a look at the first one. What do you think about that first sequence? Can you figure out what's going on there?
Is it neither?
It is absolutely neither, thank you. It is neither. Because to get from here to here, we're adding 3, but then we add 4 and 5 and 6. So remember, if you're going to be arithmetic, you have to be adding the same thing. And we're not. Okay, neither. What about this next one? What's happening here?
Arithmetic plus 3.
Yep, it's arithmetic, and the difference, we call that the common difference, is adding 3. Very good. Absolutely. Perfect. All right, what about the next one?
Geometry.
Yep, and what's my ratio? What am I multiplying by, in other words?
-7.
Perfect. It's geometric and the ratio is -7. Kids, you're sitting there with a calculator, or at least you're supposed to be sitting there with a calculator, so you shouldn't be frightened by big numbers. That should not be an issue for you. All right, how about the next one? What's happening here? What's going on in this sequence? Don't even tell me you can't tell. Arithmetic, it's arithmetic, and the common difference is what?
2.
-2. To get from term to term, I am subtracting 2. So it's -2. I'm adding -2 to get from term to term, arithmetic. And finally, what about this guy? What's happening here? Okay? You can't tell for real? Because I'm not helping them. That's 3rd grade. You guys can do it. And if you choose not to talk, that's fine.
Half.
Well, -5 is a good guess. It certainly
No,
works
minus
here.
half. Minus half. Like you're taking you're just dividing the every single.
Okay, so it's not -1/2. It's actually times/1/2. So it's geometric, and yes, you're dividing by 2 or multiplying by 1/2. So your ratio is 1/2. 10 times 1/2 is 5. 5 times 1/2 is 2.5, and it continues on. Good. Now, the next problem I want you to look at is exactly the same thing, but now I want you to actually find a term of it. So look at this sequence. Figure out if it's arithmetic or geometric. And then we're going to find the 16th term. Okay? So is it arithmetic or geometric? it's geometric, I'll be multiplying by the same number. So what am I multiplying by?
Never mind.
Yeah, that's not gonna work, is it?
Okay.
Just plus 6.
It's adding 6. So it's arithmetic, and the difference is 6. Now, we have a formula for arithmetic. The very first formula we learned or talked about right here. Okay? So we want the 16th term. We want a sub 16. So that will be the first term plus the common difference times n minus 1, or 15. 16 minus 1. N is 16, because we're finding a sub 16. So according to the formula and my trusty calculator, is that 88? I did it in my head without a calculator. Probably that was dangerous. Let's see. Yep, 88. So the 16th term of that sequence is 88. Okay? All right, try this one. Gotta find S sub 12, but the sequence is this. Okay, so before you can even start, you have to figure out if it's arithmetic or geometric. So what do you think?
Geometric.
Yep, and what's the ratio?
2.
2, perfect. So we have a formula for geometric. Right there it is, that's our geometric formula. So you have already decided it's geometric. We're summing. We're going to use this formula. We're just going to plug in. So the first term is 3. The ratio you concluded was 2. N is 12. There you go. Now we talked about this formula for the first time, I think last time we were together. And I suggested that you always simplify this first, so that's just going to be -1. So now we definitely need a calculator. 3 minus 3 times 2 raised to the 12th equals divided by -1. If you have your calculator, would you type it in and see if you get 12,285? If you don't get that, please type it in again exactly the way I wrote it right here. When you type in that 12, hit equals, and then divided by -1. All right, is everybody getting that? All right, let's do a few more, a little bit more time. Let's look at this sequence now. So write this one down and see if you can figure out what's happening with it. In other words, you're figuring out if it's arithmetic or geometric, and then you're figuring out the common ratio. Okay?
It's geometric
There.
and you're multiplying by a half.
Perfect. It's geometric and you're multiplying by a half. Now, all the problem says is find S. Now, the last one said find S sub 12. This one just says find S. What do you think that means? Kids, that's what we just did. That's your infinite series. When they don't tell you what n is, when they don't say find the sum of the first 12 or find the sum of the first 15, when it just says find the sum, it means add it up forever. So according to our formula, it's 30 over 1 minus 1/2. That's it. That's the whole thing. First term over 1 minus the ratio. So 30 over 1/2 is 30 times 2 over 1. So the answer to the problem is 60. Those are easy. Okay, we good with that? All right. Let's do a couple of limit problems now to make sure we have this figured out. So I'll just write some down. We're going to find the limit as n approaches infinity of this. So go ahead and write these down on your paper. And as you're writing them down, go ahead and write the answer down too. If you can think what the answer is, you can remember how we did these. Because these don't usually have much work to show. Now, when you're a calculus student, your professor might make you do some fancy work for it, but it's not necessary. Okay, remember this notation means we're finding the limit as n approaches infinity. That's the way we write that, the limit as n approaches infinity. And that's all we're doing. Again, when you're a calculus student, you'll find limits as n approaches all kinds of things. But right now, we're just going to infinity. All right, so let me label these A, B, C, and D. And you tell me if, and E and F, you tell me if you know the answers to any of these. If you think you know the answers to any of those problems, share them with me. These are either going to equal a number or you're going to say no limit or divergent. Okay, so does anybody see any that you can give me the number they equal, or any you know for sure are divergent? No limit.
Is it B 5 over 7?
B is indeed 5 over 7. B is 5 over 7 because we box in the highest powers and we get 5 over 7. Very good, thank you. Anybody see another one that you know the answer to or think you know the answer to?
Is it A 1/2?
Watch it. A is a little tricky. It's actually negative 1/2. Do you see why it's negative 1/2?
Yeah.
2n over negative 4n. But yes, it is negative 1/2. Very good. Very, very good. Doesn't matter that I turned around the bottom there. It's still n over n, so that's perfect. All right, anybody see any others? What about D? D's the same kind of problem. What's going on there? What's the highest? It is 0. Absolutely, it's 0. The big power's in the bottom. When the big power's in the bottom, it's 0. You have no n squareds on the top. 0 over 6 is 0. Very good. What about this one? F. Same thing. Only now the 0 is in the bottom, which means there is no limit. It's divergent when the big power is in the top. Boys and girls, we've been talking about that since about October. It's time to wake up and smell the coffee. All right, what about these last two? Now, they're a little bit different. They're not built that way. They're different. But I gave you rules about these. Who remembers the rules about exponentials when we're raising something to a power? What's the key? If this number is less than 0, or excuse me, no, if this number is less than 1, the limit is 0. If this number is bigger than 1, there is no limit. Okay. Get another sequence here. We'll try to get a couple more done. We're going to find S sub 20, that's the problem, and here's the sequence. So, as always, the first thing you want to do is figure out if it's arithmetic or geometric. So which is it? What's happening?
You're adding 4, so arithmetic.
It's arithmetic, and the common difference is 4. Very good. We're adding 4. So it's arithmetic, and we're summing, and that's this formula. That's our arithmetic sum formula. It says find the sum of 20. So this will be 20 over 2 times the first term, which is negative 18, plus the what goes here? What do I have to figure out? What is this? Isn't that the 20th term? N is 20. How am I going to figure that out? Well, I'll use my other formula, right? So A sub 20 is my first term plus my common difference times 19. 20 minus 1, 19. So I can figure out what that is with my calculator. It's 58. And that's what's going to go right here. So 58 isn't the answer. 58 is this last term that I need in order to find the answer. So it looks like the answer is 10 times 40 or 400. So the answer to that problem is 400. We we did a bunch of these the other day, and we talked about how when the formula you're supposed to use, which in this case is this one, when it fails you, or when you don't have enough information, you have to go back to one of your other formulas, and in this case, it has to be this one because this is arithmetic. These are my only arithmetic formulas. So in any arithmetic problem, these are the only two that I'll be using. So I have to use this formula to give me a number to plug into the formula I'm supposed to be using. All right, next. Hope you're writing these guys down. 12, negative 24, 48, and I want to find a sub 8. You can't do this at all unless you know what's going on in this sequence. So are we adding or multiplying? What are we doing here?
Multiplying by negative.
So our ratio is negative 2. And our formula for that makes it geometric. And our formula for geometric terms is this. So the 8th term will be the first term times the ratio to the 7th. N is 8, so n minus 1 is 7. I just type it in. So 12 times negative 2 raised to the 7th. You should get negative 1536. And if you're not, make sure you're typing in exactly what I wrote, including the parentheses. So 12 parentheses, negative 2 parentheses to the 7th power, and that should be what you come up with. All right, we're going to do 2 more here. I'm going to leave these here because we're going to need these. So I want you to look at this sequence. And I want you to decide if it's arithmetic or geometric.
Is it plus 3?
Yep, I'm adding 3, which makes it arithmetic. So this is arithmetic and the common difference is 3. Now, what the problem wants you to do is to write an explicit formula. That means these. These are explicit formulas. Now, since you have figured out that it is arithmetic, you're going to be using this one, the one with the D in it. So you'll say A sub n equals 10 plus 3 times n minus 1. So A sub n equals the first term plus the common difference that you already figured out times n minus 1. So then we just do our distributive property. And here is your explicit formula. So if you have to write an explicit formula, these are going to be your keys right here. This is going to be your starting spot. And then you'll plug in what you know. But you can't do that until you figure out what kind of sequence you've got. Because if it's arithmetic, you start here. If it's geometric, you start here. All right, last one. Sequence is 3, 12, 48. And you're writing an explicit formula. So you're doing this very same thing with that sequence. All right, tell me about that sequence. What's happening there?
geometric. and
Yep.
It's 4.
Yep, we're multiplying by 4. So for this one, we're geometric and we're multiplying by 4. So if it's geometric, we're using this as our foundation. So according to that formula, the nth term is going to be 3 times 4 to the n minus first. And you cannot simplify that. The geometric ones you can't simplify, so you're done. Okay, gang? On Wednesday, we'll do some more review. On Friday, we'll take our quiz. Make sure you're keeping up with homework due dates. All right, we have some due. I'll see you. Have a good day.
Thank you.
Thanks.
Bye. Nathan and Jaden, time to wake up.